Hve Gap Arrestor. So this is the simple circuit diagram of the Hve Gap Arrestor. One side of the Hve Gap Arrestor is connected to the choke coil and resistor to the transmission line, that is called to operator to be protected. One side of the Hve Gap Arrestor is connected to the equipment, our electrical operators. Okay, which equipment we have to protect, that connected to the one side of the Hve Gap Arrestor. For example, transformer. If we are connecting transformer here, one side of the transformer, and another side is called ground. Okay, so one side of the Hve Gap Arrestor is connected to the choke coil, to the resistor, and this like this. Construction is like this, and the second side of this Hve Gap Arrestor is connected to the ground. Okay, so this gap here, 1, 2, 3, three different types of gaps. First here, smaller distance, and 2 medium distance, and 3 larger distance. Okay, so like this, this Hve gap is constructed. Okay, so it consisting of horn shaped metal rods A and B separated by small gap. Horn shaped metals A and B separated by some small air gap. Okay, and the horns are so constructed that distance between them gradually increases towards the top of the show. Okay, the horns are constructed like this. The distance between the two horns increases in this way. Here smaller distance, here some medium distance, here a larger distance between the two horns. Okay, the horns are mounted on porcelain insulator. One end of the horn is connected to the line. One end of the horn is connected to the line, a resistor and choke coil, while other side is connected effectively grounded. In this way, one end is connected to the choke coil and the resistor, so another end is connected to ground. Okay, so the resistance R helps the limiting the flow of current. So what is the use of resistance means? To limit the flow of current. The resistance R helps in limiting the flow of current to the small volume. Okay, and the choke coil is so adjusted that it offers small reactance at normal power frequency, that is called 50 Hz. So reactance X is equal to omega L. Okay, for normal frequency the reactance is very less, but very high frequencies, so XL is equal to omega L. So omega is equal to pi. Very high frequencies, the reactance will be very high. So that's why this design is constructed like this. The choke coil is designed that it offers small reactance at normal frequency. The choke coil, it offers at a very small resistance reactance at a normal frequency, high reactance at high frequency. Okay, very high reactance at transient frequency, that is called very high frequency. Thus the choke doesn't allow the transient to enter into the apparatus to be protected. Okay, the gap between the horns is so adjusted that the normal supply voltage is not enough to cause the arc across the gap. Okay, so normally supply voltage is insufficient to initiate the arc between the gap. Under normal condition, there is the voltage is insufficient to initiate the arc between the gaps. Okay, in the occurrence of the over voltages, spark over takes place across the small gap G, and arc is stuck. Okay, the heated air around the arc and the magnetic effect of the arc cause the arc to travel up the gap. The arc moves progressively into positions 1, 2, 3 like this. First here, then here, then finally the arc will be removed. Okay, in this way this operating at some positions of the arc, position 3, the distance may be too great. No? At position 3, the distance between the two horns is very high, so that for the voltage to maintain the arc, consequently the arc is extinguished. So in this way the arc is removed. Okay, excessive charge on the lines thus conducted through the arrestor to the ground. So this is about Hve Gap Arrestor.